Hello, good morning, good evening, depends on where you live. Do you hear me? Just give me a thumbs up or yes.
Sir, good evening. It's audible, sir.
Yeah, okay.
Yes, sir.
Thank you. Thanks for confirming.
Thank you, sir. Madam, matra ಎಲ್ಲ speakers off ಮಾಡಿ. Matra speakers ಎಲ್ಲ off.
I think my light quality is poor, so I'm not sure. I don't think you can really see my face.
Yes, sir.
Anyways, I am Arshad. I work as an engineering manager with Blackstraw Technologies, who is an AI-based solution provider and data solution provider. My background is mainly into data engineering and data management, and I work in projects where we provide AI solutions, ML machine learning solutions to our customers. In this session, I'll help you walk through some of the use cases in making use of LLMs. How do we build applications using LLMs, particularly around the theme of agentic AI? How do we build agentic AI or the multiple agents that power the whole application using the LLM in the background, right? Let me share the screen and let's start this. Okay, so as I said, I have structured this presentation as to give some background, some introduction around the concept of LLM, around the concept of training the LLMs, in some of the techniques that we use to fetch information that we can use, that we can augment the LLM to provide the answers that we look for. We will talk about RAG and KG, and then we'll move into AI agents, and there will be a demo of AI agents around the concepts in building AI agents and some further reading that you can make use of. So what is an LLM technically, right? An LLM is nothing but a transformer neural network. Maybe you can consider, you can think of it as an advanced neural network with so many layers and encoders and decoders in it, in the build. right? It is pre-trained with a large corpus of text with the idea of making it able to predict the next token, right? So the training is a long process that goes through several stages, including pre-training and several multi-tuning stages, fine-tuning stages. The main concept in training an LLM is around the concept called self-attention and multi-head, right? The self-attention is the relevance of the token, particular token, in relation to other tokens in a sequence, in a given sequence. And the concept of multi-head is gathering the attention, the self-attention, which gathering the self-attention from multiple heads, from multiple streams within the same sequence, where the different aspects or relationships in a sentence can be revealed, right? For example, in case of self-attention, if you look at this text, she placed the apple on the table, then cut it with a knife. Then the self-attention here, it tries to relate it to the apple rather than anything else, or the table, right? There is a little ambiguity whether it is a table or apple, but in this case, it actually refers to the apple, right? And this is the information that the self-attention autoregressive mechanism tries to capture. And multi-head is that there are so many relationships within a sentence, within a sequence, which technically it's called, right? For example, think about the other statement. The artist painted the sunset, layering the colors until the sky looked ablaze with fiery hues, right? Here, it makes connections between sunset and fiery hues, colors and fiery hues, right? And that's what this multi-head self-attention concept is pointing at. And here are the different stages in which an LLM is trained upon. What they call as the foundational model is coming out of the stage that we refer as pre-training, right? And the pre-training you can consider as the first phase or major phase of training an LLM, where the model learns to predict the next word using this process called autoregressive text generation. There are a few techniques to do this, but by far the famous and successful one is attention, right? The process of pre-training starts with fully random weights, and for advanced tasks like conversational agents, summarizing and translating, they would need additional training, which is called fine-tuning, right? But between pre-training and fine-tuning, to get a great performance in a completely new domain, pre-training with the large text in that domain is essential, right? To help you relate the difference between pre-training and fine-tuning, consider pre-training as reading a lot of books, right? The more books you read, you'll get more knowledge. But fine-tuning is more like preparing for a task, right? Like you prepare for an entrance examination, where you actually prepare to answer questions in a particular format, maybe MCQ or in a tricky format, right? It doesn't come just out of reading the books. You actually prepare for the examination. That's what this fine-tuning, right? In technical terms, you fine-tune an LLM model for the given instructions. Let's say we decide to pre-train a model and you have identified large volumes of text in some format, right? So as part of preparation, it involves removal of the duplicate text and removal of adverse and biased contents and the PII, personally identifiable information. So after cleaning the data set, what they do is something called tokenization. It is breaking the words into chunks and encoding these chunks into numbers. And each model, it has a specific tokenizer. Uh, and the token values will differ based on the tokenizer, right? So the tokenizer is what you can consider as the vocabulary of the model, because it is the one that encodes the tokens, which is nothing but not the full word, but a chunk of the word, roughly called as 3/4 of the word, right? And then once the sentence is tokenized, they would add special tokens like BOS and EOS, beginning of sentence and end of the sentence. And then finally, these sequences are padded to become fixed length records, right? Like a regular RNN, recursive neural network training, you will have a loss function, a gradient descent, weight adjustment, and all those parameters, right? And it is the training is repeated for multiple epochs to minimize the loss. Finally, the evaluation is performed both by humans and by using the benchmark data sets. Next comes the fine-tuning stage. While the process that I just listed down, the pre-training, it is an expensive process, right? It involves several $100,000 in compute costs, but in contrast, the fine-tuning is comparably cheaper, right? Fine-tuning makes a general-purpose pre-trained model into a specialty model, specialized in certain tasks. The best example is GPT-3 was fine-tuned to become ChatGPT, who is specialized in answering questions and in summarizing. So, as I said before, in the examination example, right, entrance exam example, the fine-tuning changes the behavior of the model. The input data set for fine-tuning phase is customized based on the expected behavior change. So when the end goal of a fine-tuned model is a chatbot, the input data set will be the Q&A pairs of instructions. And once you have the fine-tuned model, then you have a real working model ready, into which you can build applications using prompting, ragging, and knowledge graphs. I'm at the third slide, RAG. Let me know if any difficulty in hearing me, in seeing the presentation, or any questions if there are. Okay, I'll move on. RAG is retrieval augmented generation, right? And many companies are working internally in this technique, as they need to make use of their own data, right? So it is a technique to add on to the fine-tuned model, a general purpose fine-tuned model, to provide information relevant to the prompt that we are asking, and to fetch documents, to retrieve the documents from our own data store and provide a response to the question that we asked, right? It can retrieve from anywhere, and when it retrieves, it stores in what we refer as a vector DB, right? A vector DB is different from a normal SQL DB, relational database management system, in that it stores the embeddings, right? The embedding is the tokenized text adjusted to the weights of your embedding model, right? And once your data goes into the vector DB, it means it is in a multidimensional space where you can perform semantic search, right? A semantic search is based on the overall vocabulary within this vector DB, where relationship between the tokens can be computed by a cross product or a dot product of the different vectors, right? So, you know, what this says is that AI plus RAG will, in most cases, will lead to a high IQ AI. So you have an LLM, a working LLM, maybe OpenAI, right, like the Chat GPT, and add it with a RAG of your own knowledge set, knowledge store. Then when you set up this pipeline, the pipeline that you see in this figure, then that is much better than the general purpose LLM that you got, right? That you got originally. So let's take a look at this pipeline, this diagram. So it shows a quick overview of a basic RAG pipeline. It has two main stages. One is data indexing, and the other is data retrieval and generation. The data indexing is part of the initial setup, or it can be even a continuous activity in which we prepare the data that the model will use to answer the questions. So the first step is data loading. We will have to import all the documents that we want the model to access. And these could be PDFs, text files, database records, or anything. It can be anything. Depending on what it is, there will be some pre-processing data prep to make it into a format that can be fed into this pipeline. Right. Next comes the crucial part, which is called a data splitting. Right. The large documents are broken into smaller bite-sized chunks, like typically under 1,000 or 500 characters, and with some overlap, right? So the first 500 characters are taken, and then with some overlap, say some begin with now 400 to another 500. So the continuity is not lost, right? So with some overlap, the documents are broken into chunks, and then the broken chunks are fed to what we call as an embedding model, which gives back a mathematical floating point representation of these chunks, which we refer as vector embeddings, right? And these vector embeddings goes into the vector DB. Right. And in the next phase, where the actual work happens, the user comes in, he has a query. Let's say you built this whole vector DB around your company's product manuals, or the customer information, or maybe the something very technical, or in the research area, the top research area in your own field, right? The user comes in, he makes a query, right? And this query is now fed into the vector, is now vectorized, and the embedding is used to make a semantic search into this vector DB. So the user asks some question, we look for anything relevant to this question in the vector DB, right? And that may or may not give back a set of chunks, depends on the question, right? And these chunks, the vectors, are then fed to the LLM. Okay, so now you see the LLM is augmented with additional information apart from the original prompt, and using this additional information, the LLM can generate a response that will be much better than the user asking the LLM directly, right? So that's the concept of RAG pipeline. By indexing our data smartly, we can retrieve and generate the responses seamlessly. Now, the RAG is not a solution. It's not the solution for all your your search problems, right? Most of the problems today that we deal with are search, but it's not just search. There are many more things. But even within search, the RAG is not the entire solution. While RAG fares well with certain problem types, like the one that I said, typically, if there are questions that are related to the overall structure of the document, or when we are trying to compare multiple documents together, when we try to make sense of so many documents that don't fit in the context window, or different documents, say in the legal domain, for example, right? Then these tasks do not fare well with a RAG plus LLM approach. The response that we get is not as good as something that you do a manual research, which puts you back to the original place where you started, right? And there are some techniques to overcome this. They are very hacky techniques which cannot be equally reproduced, and it's error prone. Like the techniques like encoding the overall structure information in each of the text. For example, now let's say all these chunks, right? All these chunks that on the gray colored chunks are from one chapter of a book, right? Now, what they are saying is that you can take the overall summary of the book and all other books in your corpus, in your domain, and add that as well into these chunks, so that the chunk knows the overall structure of the book and the related books, right? So these techniques are hacky, but in practice, they are not really giving the expected output. So then what? What's the solution, right? That's where we get this RAG plus knowledge graphs, right? So RAGs are so far good in doing a semantic search over our documents and providing additional information to the LLM to answer our original question. But to get a well-rounded understanding of the problem, the RAG is not sufficient. And we saw that the reason lies in the way we chunk and embed, that we slowly lose the larger and deeper context in those chunks, right? So, as I said, for certain problem sets like legal documentation, where there are multiple variants of a case, there could be a case, a property case, say for example, you will find a positive judgment in one instance, but a negative judgment in other instance. But there is a slight variation between them, which this RAG-based technique may not be able to identify, right? So for these kind of problem sets, the knowledge graphs are considered to be giving a much better response than plain RAG plus LLM, right? So what are knowledge graphs? Knowledge graphs represent the information in a systematic way as a network structure which reveals a connection of entities, right? Knowledge graphs are fundamentally a collection of nodes and relationships. So the nodes represent the entities, the individual data points, while the relationships define what is the connection between each of these entities. Right? Then each node will have properties like owns is an instance of, right? It's very much like your class model, like class diagram. And these properties and the relationships provide additional context to the node, right? So with this knowledge graph, we get what we call as a recursive retrieval, right? So the knowledge graphs can act as a context store and trying to fix and repeatedly retrieve the information around the concept that we are searching for. So this diagram, there is a solution provider called How.ai, which is more prominent in this area, knowledge graphs. you can see a RAG implementation with KG knowledge graphs, right? According to them, the knowledge graph will not be a single monolith. It's not, it's not that you have all your legal documents, all your technical documents, they are put into this knowledge graph generator and you make one single knowledge graph. No, it's not like that. In their idea, your knowledge store will be a cluster of micrographs, and these micrographs will each be built on a different ontology, right? The ontology differs based on the context of the input queries, and over time, the response will be synthesized using these chunks, the chunks from the vector DB and the relevant micrographs. Now, to give a context, what is an ontology? The ontology is nothing but the bag of concepts, the list of concepts, and the relationships between them that you want to track, right? So I think I believe you can relate to this concept, right? Your entire technical documentation cannot be one knowledge graph, because then it becomes, number one, very complex, and number two, you can't really add all the attributes because the ontology has to be fixed, right? We'll move on. Any questions? Now I'm coming to this AI agents. So what are AI agents? You can say that simply agents are processes that makes API calls to your LLM, right? Say, for example, you write a Python program that takes some question, some user question, a very simple Python program, right? And it calls the chat interface of OpenAI, and it provides you back a response, right? Some of you must have written programs of this sort, right? Now, the question is that an AI agent? The answer is yes and no. I would say yes, because the agent, the AI agent is what it fundamentally does. It takes your input, goes to the LLM, gets some answers, and comes back. The answer is no, because the agents are much more capable of that. It's not one and done, right? You get a task and you respond to that. That's not what a real AI agentic system is supposed to do. It is more capable of in doing complex things and in collaborating between the agents, right? And the other talk that you would have heard, maybe in many subject, in any subject, in particularly in computer science, is that something is just a better form of another thing, right? And what they say is that the agents are just wrappers around LLMs. It's not. It is much more. It depends on what you feed the agents with and how you design the agents with, right? Again, what are AI agents, right? I would say it is a reasoning loop making use of the tools into your LLM. And I would say it's not a single LLM response, but iterations. It makes multiple iterations until the goal is reached. The best part is that these iterations do not have to involve a human. It will iterate by itself until it gets the final goal. And it can break down the complex tasks to reach the end state, like how we plan an event or a research paper or a presentation. When we want to plan a presentation, we decide on what should be the slides, where should we start and where should we end. right? The flow. So an agent is as capable of doing all these things, break down a complex task to reach the end state. So what makes the agents work? These are the three things: the role play, focused inputs, and the workflow, right? The role play is a concept borrowed from the world of theater and psychology, right? By asking the LLMs to play a specific role, we can get more engaging, context-aware responses. So we make agents fitted into the different roles like a welcoming assistant, a product support agent, or a store manager, or and by handing out different tools in their hands, we get more human-like responses, right? So it is asking the LLM to play a certain role, and by giving the tools relevant to that. The next is focus. Agents get their focus with the prompts and additional context. So techniques like few-shot prompting, we instruct the agent to think in terms of the role that we want it to play, right? Few-shot prompting is nothing but giving few examples of how to respond. And using these role play and focused input, they can make an workflow by reacting, by collaborating and adapting and moving on. And we all know that the LLMs are non-deterministic, right? There is less guarantee that it will provide the same output the second time. Non-deterministic. LLMs hallucinate. Is that a problem? Again, the answer is yes and no, but actually, the truth is, it is this fuzziness that helps the LLMs break out of a closed tunnel-like situation, but to explore alternate ways out to reach the goal. So thus, unlike a standalone LLM, the agents perform tasks across the tools and applications to create a seamless workflow. Okay. How do you go about building an agentic system? I'll tell you some real-life agentic AI implementations that you can take inspiration from. There is a famous telecom provider in Canada, Bell Laboratories, and they have implemented a system which assists its customer care representatives by, they have set up an agentic AI system which listens to the calls that we make to the customer care center. By listening to the conversation and parallelly fetching the most relevant information the customer care person will need, right? So it helps the actual human agent by listening to the call and by providing the information that he would need. And I think this is important, right? They didn't replace humans with AI agents. Although today we can make LLM to talk like a human, instead, the company, they enriched their customer care by reducing the wait time spent in keeping the customer on hold state. Another example is that the Brazil's largest blood bank, it has built a workflow that tracks a list of donors and current demands, and it automatically gets their schedules for blood donation based on the demand. And in practice, we see many software companies, they have provided coding assistance agents to their employees, reducing the time spent on searching and debugging. So these are, if you think about building an agentic system, these are inspirations that you can take from. So what are all the functional components of an agentic system, agentic AI system? I would say these are the functional components that make an agentic system work, right? The agent itself, the particular agent that you create, you code. And then the most important thing is the memory and the tools that you supply, right? On the right side, it's a snip from NVIDIA's website that this is an illustration given by NVIDIA on an agentic system. The core, the agentic core, represents the decision-making power of the agent. So it uses various prompting techniques to gradually move towards the ultimate goal and completing the given tasks. The next crucial part is memory, that is necessary to maintain the context and the interactions it has performed. We want our agents to not choose a path that failed in the previous iteration, right? So that's where the context of conversations and the long-term memory, where the agent can maintain the context across the conversations over time, is important. And finally, there are so many tools available, for example, to search over the internet, to download something, to build a vector DB. Countless tools are available depending on the framework that you choose to work on, right? And finally, the most important part is the planning module, or what we would call as a supervisor agent. It's not that you have to design your agentic system with a supervisor agent, but you will understand that an agent that has been tasked to do supervisory tasks will make the system much more agile and functional. The supervisor agents, it can delegate the tasks to other agents, review the outputs made by the worker agents, and make sure it conforms to the requirements, the actual requirements of the task, right? Now, how do we go about designing our own agents? Let's say we want to build an agentic AI system that, let's say, a vacation planner, right? So my intention is that I want to book a holiday trip with 3 of my friends, and we are in busy schedules, each one of us, right? But there is an app, an agentic app that sits in the middle that can do this today, right? So, just think, forget about AI, forget about LLM. Think, what are all the capabilities that we would need? We need, all we need in a straightforward situation. Now, if you take Expedia or any hotel booking app or travel booking app, all it gets is your dates and your destination, and it can book you the tickets, right? But in real world, there is complexity. There is an ambiguity. Say, when you are a group of friends, even finding the dates that are common among you is a challenge, right? So for that, we can make what we can call as a calendar agent that can scan your calendar, email calendar, takes a manual input and provide a possible list of dates for each person, right? It need not just automatically scan the calendar and provide all the dates. It can still get some human inputs to provide the best available dates, right? And then you need a destination planner, which will give a list of destinations, or it can take a list of choices and provide a fine-tuned list of destinations, right? And you will have to have a travel ticket agent, right? The ticket booking agent, now in this case, will have to wait till the dates and destinations are available, right? Now, you have these 3 different agents and you can build this thing, but let's stop at this point. We can write a software today, right? Without AI, without LLM, we can write a software to do all these things, but think about the complexity of the software, right? It becomes complex when you add the elements like the ticket agent will have to wait until you get the dates and availability. And we can increase the complexity, right? Now, once the dates and destinations are known, the ticket planner will have to look for a cheaper transport and accommodation options. And if the ticket prices are exceeding the budget, right, then we have to think about our whole vacation plan, right? We have to ask for a change in the destination or the dates. And finally, before booking, let's say you finally got some dates and everything worked out, we have to ask for confirmation before the booking, right? So once they all confirm, they book the tickets and email the tickets, and it can go on. The calendar agent can go on to block those dates in our calendar. Now, this app may or may not be existing, but if you were to build an agentic AI to do this, now these are all the minimum things that you will have to consider, right? And building this is not tough. It's easy. I'll tell you. We'll move on. I'll move on to the next case, which is our demo part, right? I have an AI tutor, right? And this tutor app can conduct quiz to any student on any subject, right? And this is not a fully made app. It's something which you should see as a demo, right? Now, again, come back to the design process. What do we want from the app? The student should be able to choose a subject area, right? Meaning, once the student chooses a subject area, the app can suggest subtopics. For example, if the student chooses data structures and algorithms, the app can go down and say, you want to take quiz on linked lists, on graph structures, or big O notation, right? It can suggest the subtopics. Then after back and forth, there is a back and forth, the student confirms a topic to get quiz questions. Now, once the student confirms a topic, the app goes back. The app doesn't know anything, right? So it has to scan the internet to collect the knowledge resources, any knowledge resources that is relevant to the subject that the student chose, right? And then once it got the resources, knowledge resources, say a PDF or a class notes or a PPT or a book, textbook, right? Then it creates questions in multiple choice question format. And it also has to know the correct answer so that the student can take the quiz and grade it, right? Okay, now I'll do the demo part and then I will explain what are all the components in that. So this little app that I have built to showcase the agentic framework was built using Crew.ai. Crew.ai is one of the framework. The most popular is LangChain and LangGraph, but a Crew.ai is an abstraction on top of LangChain, I believe. And then the Gradio is a Python tool, that Python package that you can use to make some UI, quick UI, right? Now, in this case, demo, I have multiple agents, at least 3 different agents. One does the task of a professor who frames the questions and the answers. And the next one is a teaching assistant who would look for knowledge resources, right? A PDFs or a book. And finally, the task of a librarian. If you walk into a college library and you ask for a book or a suggestion, the librarian can guide you to the shelf, right? Or he can even provide you the subtopics because he knows a multitude of topics, but he is not an expert in any of them, right? And then these agents are given a set of tasks and a set of tools. I'll break now. I hope the demo works, right? You see my screen, the demo screen? Do you see a Gradio app? Are you there? Can someone confirm? I think yes, but if I get a confirmation, that's much better. Okay. Okay, so as I said, I said there are three different agents working, right? The first agent is a librarian. If you give any concept, it will immediately come back with a set of suggestions. I say data structures and algorithms, right? It gives a set of suggestions, right? And then let's say it can be anything. Let's say I talk about bike repair. And it talks, I have coded in such a way that it just gives me 5 suggestions for each of the topic, right? Then I say neural network. So this is the librarian agent, which I'll talk about how the prompt was given to this librarian agent. Now, in our actual case, let's say we want to go deeper into a topic, say convolutional networks. Right, then it will suggest more subtopics like the architecture, transfer learning, regularization, all these things, right? Let's say I want to go with the convolutional networks. Then it's going to go for, now all these things are happening in the background. It's going to go to look out for the resources, and it will pick one resource that it can use to build a RAG DB using it is actually looking for a PDF, right? It looks for a PDF, it builds a vector DB using this PDF, and then it will scan through the PDF to look for areas where it can ask questions, and then it will come back with a set of questions, right? I have limited this to come back with just 3 questions to limit the amount of token spend, right? So here are the questions. There is a question, there are multiple choices, and there is a correct answer, right? Now, with more prompting, we can get these questions in different levels of complexity, and you can make a better UI out of it that you can use. You can use it as a real quiz application, right? Any questions before we move on what is working in the background to get this app work, right? So as I said, there are 3 different agents, right? Professor, teaching assistant, and librarian. Here is the first agent, which is the agent that suggests the subtopics under the topic, right? I told you that the entire framework was built on Crew.ai, right? Crew.ai, in order to build an agent out of Crew.ai, you have to give 3 different parameters, 3 different arguments: the role, goal, and backstory, right? The goal and the backstory gives enough contextual information to the LLM on what role it has to play. Remember, role playing and focus from one of the previous slide. So what I'm saying this agent is, what I want this agent to be is, it has to provide me the subtopics, right? And I'm saying that you will have the knowledge of a public librarian, just surface level knowledge. You are aware of all the numerous subjects and their branches, right? and you know how to organize the information effectively, but in general you are not knowledgeable within that subject. So this is the agent that went into the LLM to ask for subtopics given a topic, right? Then the next agent that works is the topic researcher and lecture assistant. The topic researcher, its function is once you give a search idea, right, some topic to search on, its task is very simple. It goes and gets all the top links. And in order to make this work, I have used what they call as a Serper.ai API, right? The Serper tool. Then comes the lecture assistant. The lecture assistant's role is in finding out the books. Now, the research assistant, the topic researcher, will throw a list of links, one or two or 10 or 20 different links. Out of it, the teaching assistant will have to find the best link, right? So once you found a suitable link, you will have to download that link and add it to the vector DB so that the professor can ask questions that can get the questions and knowledge out of that DB, right? And what you see is what that actually goes into building these agents, the role, goal, and backstory of each of the agent. And finally, here is the AI, the professor, right? And here, if you notice, I'm saying that the professor is an expert. He's a professor in, and there is a placeholder, right? So the initial topic that I gave, say convolutional neural network, that will be fit into this input topic during runtime, and the agent will become a professor in neural networks, or a professor in bike repair, or a professor in computational biology, right? And he has a goal. The goal is to make multiple choice questions from the given resource, right? And the backstory is that you have experience in conducting quiz and evaluation assessments and use the available tool. In his case, the tool is the vector DB. Scan the vector DB and pick random questions, right? In fact, it's not random question. I have given instructions on how to look for areas to ask questions. And it's not just picking the question. It also has to come up with answers in multiple choice format, right? One of the choice will be the right and others will be wrong. So we are instructing the agent to do all these things together. And if you notice, the tutor will not begin his work until the topic librarian and the research assistant have done their job, right? And if you ask the core code about this, it's this, just 130 lines. Just 130 lines of Python code. The prompts that I gave for agents, that goes into the YAML file, right? The same things that I showed, where I defined the agents and the task for each of the agents, right? And if you notice, here I'm saying for each concept, start in the table of content and get the list of concepts available. And just pick 3 random concepts. And for each concept, search the corresponding chapters, right? And I'm instructing use the PDF search tool, which does a RAG-like search on the extracted data source, right? Now, in this case, when I ran this entire thing, so it downloaded this. I think this is the one which it downloaded recently, right? And it built a DB, a vector DB, using these sources. Finally, So these are the other agentic frameworks that you can explore: LangChain, LangGraph, and Dyna AI. And you know, the entire framework that I just said, right? It can also be automated using low code automation tools. The first two, these are the three that has got a lot of traction. The first two are commercial tools. The NA10 has a commercial offering as well as an open source offering, which you can use to install in your local and build graph-like workflows, which does all the things that I mentioned. I think I reached the end of the presentation. You can, if you want, I can share this presentation to you. Let me know. You can drop your emails in the meeting chat, or maybe you can reach out to the organizer. I can share the presentation. If you want, I can also share the code that runs this particular app. Any questions? Any comments, feedback?
Any questions from participants? Kindly ask them. Any questions?
Okay.
Okay. Thank you, sir. Thank you for
Yeah.
sharing your expertise and providing valuable insights. Your knowledge
Yeah.
and experience has truly enriched us today, sir.
Thank you, ma'am. Thanks for the opportunity. Yeah, bye.